So question 26. Two waves, two wave pulses are traveling towards each other on a long rope. The pulses have the same amplitude and wavelength and are traveling at speed 0.5 meter per second. And the wavelength and amplitude is same. Which diagram shows the rope at time t equal 3 seconds? So now first we are going to find from this if we can use the formula for this question. And this is our amplitude, that one is same for this and this one. Left right both have the same amplitude. Wavelength is, if we are considering from here to here, that is 0.5. So the wavelength should also be the same. And we can use the formula F equal V by lambda. V is 0.5 divide 0. 0.5. The value is same, so we are going to get 1 hertz. And if you can find the time period should also be 1 second. So it's mean that for one wavelength the time is 1 second. So when we have, suppose if we can move from this point to here, if I can extend this one, so this is 1 second. So third, after 3 second, after 3 second, the this position, this is the position that, suppose if I am saying that this position is A, this position after 3 seconds this should be here. Now if we can, suppose if I am saying this is P position here, now after 3 seconds we can see that what's going on to that one. 1 2 3. So when this one is going this way with 3 seconds, so the P point comes to the A point. So we can say the crust combined with crusts and the trough combined with troughs. So what's going on in that situation? When the crust combined with crust and trough combined with trough, so the amplitude increases in that one, and so we get constructive interference. So we can say that at 3 seconds later, when both the waves from the right and left travels in their direction, this and this way, the crust combined with crust and trough combined with trough, and that causing constructive interference, So the answer should be C. So this is our, you can say, the answer for that here. So we get the constructive interference for that. The rest are not possible. Next question is about diffraction of waves. They said water waves of wavelength lambda are incident normally on the obstacle with narrow gap. The width of the gap is equal to lambda. This width of the gap is equal to, so it's mean lambda equal width of the gap, if I'm saying this is d here, and this is our wavelength, the distance between wave fronts, and the gap is here, the angle is given to us, that one is theta here, and they said that the gap is slowly widened. We are increasing the d value, which change, if any, occurs to theta and wavelength of the emerging waves. If possible, you can keep one formula in your mind. That one is for single diffraction. when we have single slit diffraction, we have the formula that is theta equal lambda over b. B is basically the slit separation here, and theta is the angle. So in that situation, when we are increasing this value, the b we are increasing, so what's going on to the theta value? That one decrease. And keep it in mind, in diffraction, the wavelength doesn't change, that remains same. So it's mean the theta value decrease and wavelength remains same. So we can say our correct answer is A. And this basically this formula we are getting, that one is d sine theta equal n lambda. And if suppose for first minima we are considering n is 1, this is wavelength, and this one I am saying b, and this sine theta is very small, that nearly equal theta, so we can say theta equal lambda over b. So this equation, if you can keep in mind, that makes easier for us. Question number 28 is about the diffraction of light. So for diffraction of light, the first thing that we need to keep in our mind, that one is the formula for diffraction of light. That one is d sine theta equal n lambda. The light of wavelength 720 nanometer from the laser X is incident normally on a diffraction grating, and diffraction pattern is observed. Light from a laser Y is then also incident normally. So it means the angle is same. Sine theta is same for both, for X and Y on the same grating. The grating is same. The third order maxima due to the Y. So it's mean for Y n is 3, and same place for X is 2. N is 2 for X and n is 3 for Y. What is the wavelength of light from the laser Y? So we are going to find the wavelength of Y, lambda Y. So as we know that our formula is d sine theta equal n lambda for X and Y. This is suppose X, this is Y. So we can say sine theta is equal to sine theta of Y. This is given to us incident normally in both, so thetas are same. Then we can write it as for the X, we can say n lambda over d for X equal n lambda over d for Y. As we know that n for X is 2, so I'm going here, so 2 lambda over d equal 3 lambda over d. And in this case, that we can say that the d is also same, diffraction grating is same, so this is okay. So it's mean 2 lambda X equal 3 lambda Y, and we are interested to find the wavelength of Y. So the lambda Y equal 2 by 3 into lambda X, and the answer is 480. 2 by 3 into 720, and we can simplify it, and our answer is 480 nanometer in there. Question number 29. Again, the question is about the diffraction grating. Comparatively easier question. Monochromatic light, single color, single wavelength light, single frequency light of frequency f is incident on a diffraction grating of line spacing d. The speed of the light is c, which expression can be used to determine the highest order of intensity maxima produced by the grating. So we are going to find highest order means n. As we know that our formula for highest order we get, the first question is the highest order. Highest order we get when the angle is 90 degree in that. So this is one information for us. So it's mean, and if we can see that the formula is d sine theta equal lambda, as we know theta is 90 degrees, so sine 90 degree equal 1. Now, as we know lambda equal c over f, v by f, or c by f here, that is given. Now we are going to use the formula again, d sine theta equal n lambda, and we can write it as this is 1, so d equal n lambda, and instead of lambda we can plug the value, so d equal n c by f, c divide f, and when we are going to rearrange the equation, so we get n equal df over c, df over c, so the correct answer is B. Question number 30. A metal plate of uniform thickness is connected to a cell as shown. This is cell, this is metal plate. Electrons move clockwise around the circuit. Always electrons are going, this is negative, this is positive. Electrons are going to the clockwise, this way, flow of electrons. While we are considering the conventional current, that one is going anti-clockwise. So if we can see, this is positive, this is negative, so the electric field set up from positive to negative here. While the electrons are going opposite to the electric field, when they are moving opposite to the electric field, we get drift, you can say that the speed. Opposite to the electric field, we get drift speed in that one. Now, as we know that the electron moves clockwise in the circuit and the current flows anti-clockwise direction. So if we can see the answer B, they said the average drift speed of conduction electron increases as they move from right to left. This is right side, this is left side. So it's mean when they are moving here, so average, you can say the drift speed increases, conduction of electron increases as they move from right to the left. So we are saying as the average drift speed of the conduction electron increases as they move from right to left through the plate. This is true since the current is in opposite direction compared to the EMF orientation in that one. So our correct answer is B. Now question number 31. Question number 31, they said the diagram shows the direction of the current in the metal block. The change carries the charge carriers, the charge carriers enter the block through the face P, Q or S and leave the block through the opposite face. So here they enter, P, Q, R, S is the entering one and the opposite way they are leaving in that one. So they said the number density of the charge carrier is N. Each carrier has a charge E. The average drift speed of the charge carrier is V. Which expression gives the current in the block? So we are going to find the current. We have the equation. Even this equation is given to us in our paper on second page of our paper. NEVA, where we know that the I is the current flowing in the conductor, N is the number density, that is the number of charge carriers per unit volume. That's why the unit is centimeter per centimeter cube or meter cube. E is the elementary charge, V is the average drift speed of electron, A is the cross-sectional area of the conductor. So now if we can see our equation is this, and this equation, if we can change the parameter I equal NEV into area, we can write it as X times Y. doesn't matter, we can change. Area is basically x into y. Now after this, if we can see, our equation become I equal E N V x y. So this is our equation. So the correct answer is B. Question number 732, sorry. Question number 32 said, what could not be used as a unit of potential divider? What could not? So be careful, not is bold. So many students, they make the mistake, they are not reading the question properly, and so the problem comes. And you can define the potential difference through different ways. V equal IR. Second one, you can also write it as V equal P over I. You can also write it as uh, P equal V square divide R, or you can write it as V equal PR square root. And if we can see in this one, and if you can write the unit, first one is the ampere into resistance. The second one is power over, you can say, the current, and current equal Q by T, and then you can simplify that one, and then you can see the unit of this power. So if you can see the C1, that we can write it as the watt over ampere. So it's mean this is C is correct for this equation. Similarly, if you can see that one, so this is correct for this equation. So it's mean that the equation, that's not possible for us. There is no equation for this. So it's mean that our correct answer is B. So it's mean the B is not the unit of power. The rest we have already checked from this satisfying this satisfying this, and the D answer satisfying by this equation, but there is no equation